Let us talk about various communication channels. In various communication channels, we will be talking about, say, free space communication. We will be talking about the satellite communication. And the third thing we will be talking about, that is line communication, in which nowadays in your syllabus you have optical fiber. So we will be concentrating only on optical fiber. We will not be talking about the resistance, inductance, capacitance combination earlier you used to have in your phone system of line communication. If you talk about free space, then there are main three discussions you will be having. One is called ground waves, another one is called sky waves, and third one is as used by your cell phones, that is called free space communication or space communication or line communication, line of sight communication. All such names have been given to the third part. Understand? Space communication or line of sight communication, that is a name given to third part. When you have satellite communication, then you should understand that any particular country such as India, what kind of satellites they are using for communication. There are mainly two types. One is your geostationary satellite, another one is polar satellites, which is used for remote sensing. So we will be talking about that. And at the end, we will be talking about the way optical fiber is communicating. So let us first talk about free space communication, in which first we talk about ground waves. What you are calling ground waves, इसको पहले हम मीडियम वेव भी कह रहे थे. इफ यू रिमेंबर, हमने AM बैंड में MW लिखा था. दैट वाज एसेंशियली दिस ग्राउंड वेव, जिसकी रेंज अप्रोक्सीमेटली आपने 1600 किलो हर्ट्ज तक देखा था. अंडरस्टैंड? ये हमारी फर्स्ट ट्रांसमिशन ऑफ इलेक्ट्रोमैग्नेटिक वेव्स थी. इसकी मैकेनिज्म कुछ इस तरह की. लेट्स सपोज दिस इज द अर्थ ओवर विच यू आर ट्राइंग टू डू द कम्युनिकेशन. So here the modulated wave, they are vertically polarized. इसमें अगर आप एटमॉस्फेयर के सारे चैनल्स को देखें तो दिस इज द लोएस्ट एटमॉस्फेयर लेवल विच यू कॉल ट्रोपोस्फियर. एंड उसमें जो भी आपकी, लेट्स सपोज दिस इज द रेडियो स्टेशन फ्रॉम विच यू आर ट्राइंग टू ट्रांसमिट दी वेव्स. वेव्स की एम्पलीट्यूड के पॉइंट ऑफ व्यू से देखें तो वेव्स अगर वर्टिकली पोलराइज्ड है, जस्ट इमेजिन दैट अ वर्टिकली polarized wave has started from a particular place and trying to move from one place to other place. So in this case, the wave comes, hits the ground, then goes up, comes, hits the ground. जब भी ये wave ground को hit करती हैं तो ground में charge की generation होगी, because in electromagnetic wave you have already seen that electric field is the one which is the dominant one. So वो ground में कुछ charge create करता है. Now this charge has to move through the ground. But the wave which is there in the air, it can move freely, but the movement of charge in the ground, that will be slow. You understand? Wave ऊपर जा रही है and all the time it will be connected to the charge it is producing in the ground. So what happens that the wave has to come back because the movement of charge is slow, but the movement of wave in air, that is faster. So gradually what happens that the wave diminishes. This is the way it is moving on. वेव ऊपर जा रही है, वर्टिकली पोलराइज्ड है, ग्राउंड को हिट कर रहे हैं, फिर ऊपर जा रहे हैं, ग्राउंड को हिट कर रहे हैं. दिस इज द वे वेव्स आर मूविंग, इजंट इट? बट द मोमेंट इट इज हिटिंग द ग्राउंड, ग्राउंड में चार्ज की जनरेशन हो रही है, और ऊपर जो वेव जा रही है वो स्पेस में है, तो स्पेस में उसकी स्पीड ज्यादा है, ग्राउंड में उसकी स्पीड स्लो है, एंड ग्रेजुअली ये डिमिनिश हो जाती थी. दैट वाज द रीजन कि इसकी रेंज बहुत ही कम होती थी. यू अंडरस्टैंड? जो शुरू में हमारी मीडियम वेव्स या ग्राउंड वेव्स प्रोपेगेट होती हैं या होती थी, अब ये थोड़ी सी कम हो गई हैं, लेकिन जो भी मीडियम वेव की ट्रांसमिशन थी उसकी मेजर प्रॉब्लम ये थी कि द रेंज वाज लेस, फ्यू किलोमीटर्स. बट द एडवांटेज वाज दैट इट हैड वेरी लेस डिस्टर्बेंस. फॉर एग्जांपल रेनफॉल हो रही है, लाइटनिंग इज स्ट्राइकिंग, जो भी थंडर स्टॉर्म्स हैं, दे वर नॉट रियली अफेक्टिंग दिस वेव, बट अगर अक्रॉस द ग्लोब या लॉन्ग रेंज ट्रांसमिशन होती तो उसमें ये प्रॉब्लम आ सकती थी. दैट वाज नॉट द केस so long as ground wave or medium wave was concerned. Now, as you had this problem that the range was less, to increase the range, we had other kind of wave which you used to call sky wave. Let us talk about that. In the next higher free space communication, we are talking about sky waves. They were also called short waves. And what we mean by short wave is that the wavelength has become short. अगर आप इसकी फ्रीक्वेंसी रेंज देखें तो अप्रॉक्सीमेटली 10 मेगाहर्ट्ज तक चली जाती थी. एंड इफ यू कंसिडर द मैकेनिज्म ऑफ दिस ट्रांसमिशन, then you already know that there are several layers of your atmosphere. Let's suppose this is ionosphere, and mesosphere, stratosphere, troposphere. जो ground waves थी वो troposphere तक confined थी. The range was less. But let's suppose you have to have a higher range. Communication ज़्यादा दूर तक होनी चाहिए. Then you see it's a general rule that in case frequency of a wave is higher, then it will have a larger penetrating capacity. So what we used to do from a tower, radio station, whatever you have, transmitter, a higher frequency wave was thrown. Now in the ionosphere, what you have, in the daytime, there is a regular making of ions because of the sunlight. Ions are getting formed. In the daytime, there is large amount of turbulence so long as ion formation is concerned. Daytime में ions बनते रहते हैं, खत्म होती रहती हैं, बनती रहती हैं, खत्म होती रहती हैं. उनकी जो number density आप देखेंगे, that is highly fluctuating so long as daytime is concerned. But after the sunset, whatever number of ions were produced, that was stabilized. What I have written here, Nmax, is the number of ions per unit volume present in the ionosphere at night. क्योंकि जब सन वहां पे नहीं है तो कोई यहाँ पे डिस्टर्बेंस नहीं है, वट एवर फाइनल आयन्स हैव बीन प्रोड्यूस्ड वो वहां पे स्टेबलाइज हो जाती थी. एंड दैट वाज द रीजन दैट शॉर्टवेव बैंड पहले जो भी स्टार्ट होती थी उनकी ऑपरेशन डे टाइम में बहुत ही कम, आफ्टर सनसेट इनके सारे स्टेशंस खुलती थी. बिकॉज नाइट में ये फ्रीक्वेंसी या कहो कि अभी आप the maximum number of ions which were there in ionosphere वो stabilize हो जाती थी. Now why are we relying on the stabilization of this ions? I will explain it to you. There was a kind of, you can say, critical frequency जिसकी फॉर्मूला हम लिखते थे 9 times the square root of maximum ion density you could have in the ionosphere. You see, beyond ionosphere you have nothing, and ionosphere is having a medium. Now it is something like total internal reflection of the wave. जब ये waves ऊपर जाती थी तो ions को hit करने के बाद ions की density को भी थोड़ा change करेंगी. So you can understand that from this is high refractive index medium, the wave is entering the low refractive index medium. बाहर में उसकी density बहुत ही कम हो गई तो इन waves की total internal reflection होती थी. Now which maximum frequency will be undergoing total internal reflection? That is being given by this formula. This is the critical frequency. FC is critical frequency, means beyond this frequency a wave will not be reflected. Do you understand? This wave was traveling through the sky, or you can say getting reflected by the ionosphere or sky wave. That is why it was given the name short wave or sky wave. And the advantage of this was that it had the larger range. But the disadvantage is that whatever disturbances are there in the atmosphere in between, they will severely affect your transmission. So this is the problem involved with the short waves. Now if you want to have the higher frequency transmission, because constantly you have the need that higher and higher frequency transmission should be there, so atmosphere will not be a reliable thing. Because let's suppose you are firing higher frequency, जैसे ये 10 मेगाहर्ट्ज तक हो गई, तो अगर आप मान लीजिए कि FM ट्रांसमिशन करना चाहते हैं which is having say 100 मेगाहर्ट्ज, उससे भी ज्यादा है, So that frequency, in case you will be throwing in the sky, it will simply be penetrating the sky and going away. It will never be able to come back. So higher frequency transmission was not possible so long as our atmosphere is concerned. तो उसके लिए आप डायरेक्ट ट्रांसमिशन करते हैं, और विच यू कॉल स्पेस ट्रांसमिशन या स्पेस वेव्स. सो लेट अस टॉक अबाउट दैट. The third kind of transmission we have in free space, that is called space waves, or this was also called line of sight communication. As the name suggests, if you have a frequency higher than the frequency of sky waves, then इनकी ट्रांसमिशन के लिए आपको लार्ज साइज एंटीना क्रिएट करनी पड़ती है. फॉर एग्जाम्पल, कंसिडर अ टीवी टावर. Why do you have a TV tower of larger height? The reason for is that, let's suppose this is the height of the TV tower you have. Now see, if it is radiating waves of higher and higher frequency around say megahertz, then whatever is going up, that will not be coming back. Now whatever is the direct transmission, that means अगर आप इस टीवी टावर के ऊपर पहुंच जाएं और वहां से सारे डायरेक्शन में देखें, so up to whatever distance you can see, that will be called the range, because this is a direct transmission you have to provide. अगर आप डायरेक्ट ट्रांसमिशन करेंगे, देन ओनली इट विल बी रीचिंग. आप उससे ज्यादा फ्रीक्वेंसी जो ऊपर गई, दैट विल नॉट बी कमिंग डाउन. सो आपको ट्रांसमिशन के लिए जितनी दूर तक साइट आपकी जाती है, दैट इज व्हाई द नेम इज लाइन ऑफ साइट कम्युनिकेशन. जितनी दूर तक भी आपकी साइट जाती है, उतनी दूर तक आपकी कम्युनिकेशन हो पाएगी. नाउ द लोअर पार्ट विच आई हैव ड्रॉन, दैट इज एसेंशियली द सरफेस ऑफ द अर्थ. यू अंडरस्टैंड? If you join this side, this is 90 degree, this is going to be the radius of the earth. You understand? In a simpler fashion, you can say, if I go by the geometry, this is the radius of the earth, this is also radius of the earth, this is the height of the antenna you have or TV tower, and let's suppose this is the range. Now if I ask you to calculate the value of this range, then you see, here you have a right angle triangle in which, let's suppose this is the base, this is perpendicular, and r plus h is the hypotenuse. So you have, going by the Pythagoras, x square plus r square, this is equal to r plus h whole square, isn't it? I am interested in finding out what is the range of my line of sight communication in case I am having a TV tower or antenna height as h. Here r is radius of the earth. If you expand this particular expression, then you have r square plus h square plus 2hr. Now this r square cancelled. Since h is very small compared to the radius of the earth, the square is further small, so you can neglect that, and you will find that the range x, this is equal to under root 2hr. Understand? This is the range. Now what is h here? H is the height of the TV tower and r is the radius of the earth. Now let us take a practical example. Let's suppose in India you have a TV tower of height say 110 meter. For example, TV tower in Delhi you have, that is a height of around 110 meter, and radius of the earth, this is around 6400 kilometer, isn't it? So if you calculate the range x as per this formula, this will come out to be around say 38 kilometer approximately. That means if a TV tower of height 110 meter is doing direct transmission, then people up to 38 kilometer will be covered. If you talk about the area on the earth where you are having the coverage, then you can use the formula pi r square, and radius will be this 38 kilometer, within which you can have the direct transmission. Understand? Now generally the TV towers are kept high because from the TV tower the sound transmission, that is in higher range, in the FM mode. So naturally the area of coverage is more, but let's suppose you have simply FM radio stations, then the height is not very large. That is why the range of FM stations, that is very small. And if you want a larger transmission or up to a larger range, then you have some repeating stations. Repeaters are regularly kept. Now remember that on the similar principle, you have the working of a cellular phone. So let us talk about the line of sight communication and cellular phone aspects, how it is communicating. In the cellular phone communication, as the name suggests, why do you call it cellular phone? Because you have any city, any area that is, you see, divided into certain cells which are hexagonal. जो भी bee hives की shape होती है, उसी से हमने inspiration derive किया है, because this is the kind of shape which is very symmetrical and it covers every area. मान लीजिए आपने एक एरिया को सर्कुलर सेल्स में डिवाइड किया होता, तो यू कैन सी दिस मच इज द एरिया विच इज लेफ्ट ओवर. पूरी सिटी आपकी कवर नहीं हो रही है. बट इफ यू आर हैविंग हेक्सागोनल सेल्स, देन यू कैन कवर द इंटायर सिटी. जनरली साइज अगर आप इसका देखें तो इट डज नॉट गो बियॉन्ड 1 किलोमीटर. ये साइज जो है 1 किलोमीटर मैक्सिमम रेंज, इवन मच लेस देन दैट. एंड एट द सेंटर ऑफ ईच you have a tower. Let's suppose you are standing here. You are standing here with your phone. Then you are into this cell, और इसके अंदर जितने भी लोग होंगे, they are connected to this tower. And let's suppose the person to whom you are talking, he is standing few kilometers away from you, and probably he is somewhere here. Then his interaction is with your this tower. बिकॉज आपके सेलुलर फोन की रेंज बहुत ही कम होती है, तो एट द मोस्ट इट कैन गो टू द लोकल टावर, बट यू आर एक्सपेक्टेड टू टॉक टू पर्सन हु इज क्वाइट फार ऑफ फ्रॉम यू इन द सेम सिटी, लेट अस सपोज. देन वट एवर यू विल बी डूइंग, योर इंटरेक्शन विल बी विद दिस टावर, एंड दिस टावर विल बी सेंडिंग इंफॉर्मेशन टू द नेबरिंग टावर्स. Then this tower will be sending information to the neighboring towers, and finally that will be delivered to the person with whom you are trying to talk. You understand? Now the problem is that these towers are of lower height. आपने देखा होगा generally these are put on some building. बिल्डिंग की हाइट बहुत ज्यादा नहीं है. नेचुरली अगर इसकी हाइट ज्यादा नहीं है तो इसका रेंज भी क्या होगा, बहुत ही कम हो जाएगा. नाउ दिस इज द टॉप व्यू ऑफ द सिटी आई हैव ट्राइड टू शो. नाउ इफ यू सी द फ्रंट व्यू, देन इट इज समथिंग लाइक दिस. ये देखिए आपके अर्थ की रेडियस की कर्वेचर है, एंड इफ यू ड्रॉ दिस टावर, तो इस टावर की हाइट जो है वो हम ऐसे दिखा रहे हैं. दिस इज द ट्रांसमीटर. यू अंडरस्टैंड? यू आर स्टैंडिंग समवेयर हियर, और आपकी इंटरेक्शन इस टावर से हो रही थी. नाउ इट हैज टू बी सेंट टू समवन हु इज हियर, जो कि काफी दूर है, और मे बी यू टॉक दैट ज्यादा से ज्यादा इसकी ट्रांसमिशन एडजेसेंट टावर में कहां तक हो सकती है. नाउ यू सी, अगर आपके ये टावर ने अपनी वेव्स थ्रू की, तो बीच में अर्थ की कर्वेचर आ रही है, यू कैन क्लियरली सी. सो ज्यादा से ज्यादा इसकी ट्रांसमिशन की रेंज यहां तक हो सकती है. अगर आप इसकी वैल्यू देखें तो दिस विल बी नथिंग बट, अगर आप इसकी हाइट HT लिख रहे हैं, तो द रेंज अप टू विच इट कैन थ्रो द सिग्नल दैट विल बी √2HT इंटू R. यू अंडरस्टैंड? नाउ बीच में कर्वेचर आ गई, द वेव इज गोइंग स्ट्रेट, इट इज कमिंग अप टू दिस प्लेस, एंड जो रिसीविंग स्टेशन है दैट शुड बी सीन बाय द हेड ऑफ दिस ट्रांसमीटर. जब तक वो दिखेगा नहीं तब तक वहां तक वेव्स आपकी पहुंचेंगी नहीं, बिकॉज वेव्स विल बी ट्रेवलिंग इन अ स्ट्रेट लाइन टू रीच अप टू दैट पॉइंट. यू अंडरस्टैंड? सो लेट्स सपोज द रिसीवर इज हैविंग अ हाइट HR, then you see this much length is √2HR into radius of the earth. Here R means receiver, here it means transmitter. अगर आप इन दोनों वैल्यूज को ऐड करेंगे तो that will be the distance between these two antennas which you have this to this distance. So since the height of the cellular phone tower is small, that is why इनकी नेक्स्ट रिपीटिंग स्टेशंस बहुत छोटे छोटे डिस्टेंस पे हमें लगानी होती है. अगर हाइट बहुत ज्यादा होगी तो आपके सेलुलर फोन के साथ इंटरेक्शन में उसकी प्रॉब्लम आएगी. इसीलिए हाइट भी आपकी कंसिडरेबल होनी चाहिए, एंड दैट्स वाई छोटे छोटे सेल्स में आपको पूरी सिटी को डिवाइड करने की जरूरत पड़ती है. wherever you do not have the cell, your cell phone will not be operating. So this is the formula you happen to get. In case we give you the height of the transmitting antenna and height of the receiving antenna, then you can calculate what is the distance between these two using this formula. Now why it is called line of sight communication? Because one head of the antenna must see the head of the other antenna, and only up to that much distance it can do the transmission, and this height of course decides the size of the cell. So these are the three popular ways of doing space communication. Now let us talk about the satellite communication. In the satellite communication, first let us talk about the geostationary satellites. Geostationary or geosynchronous. You have already studied in the chapter of gravitation that the time period of rotation of a satellite is dependent on the distance of it from the center of the earth. The famous Kepler's laws you had, that was square of the time period was proportional to the cube of the radius of the orbit, if you remember. And based on that, let's suppose this is the earth I am drawing and you are watching this earth from the south pole, then probably the shape of the earth will appear to you something like this. These are several latitudes I have drawn, and you can draw the longitudes as well. This is the kind of shape you have for the earth, and here you have the TV tower. Now just now you have seen that the TV tower, it has a limited range of few kilometers, but let's suppose you want to cover the entire globe. Now earth is regularly rotating from west to east. You can see earth is rotating and the rotational time period is 24 hours. Now based on this time period of 24 hours, you have calculated that what should be the altitude of a satellite which will also be having the same time period as that of the rotation of the earth. That standard distance has come out to be around 36,000 kilometers. So let's suppose this is my satellite 1, जो कि आपका एक जियो स्टेशनरी सैटेलाइट है, तो वो अर्थ के सरफेस से 36,000 किलोमीटर ऊपर हम प्लेस करते हैं. दिस इज अवर हेल्पलेसनेस, बिकॉज अगर वो 36,000 किलोमीटर की हाइट पे नहीं होगा, उससे ज्यादा या कम होने पे उसकी टाइम पीरियड 24 आवर्स से चेंज हो जाएगी. बट जब उसकी टाइम पीरियड एग्जैक्टली 24 आवर्स होती है, तो जब भी अर्थ रोटेट भी कर रहा होगा उसके साथ साथ वो भी सैटेलाइट रोटेट कर रहा होगा, एंड ऑल द टाइम इट विल बी अपीयरिंग in front of you. For example, if you see your dish antenna all the time in the northern hemisphere, for example in India, you will find all the time they are facing south. Why? Because पूरी अर्थ की जो अगर आप शेप देखें तो उसमें जो इक्वेटोरियल प्लेन है, in that equatorial, this is the equator, तो इक्वेटोरियल प्लेन में ही ये हमारी सारी जियो स्टेशनरी सैटेलाइट्स जो हैं वो प्लेस्ड होती हैं. एंड इफ यू सी दी वर्ल्ड कन्वेंशन, then over the entire equator it's only 360 satellites that can be placed. So our India's satellite, it is just ahead of that, और हमारी सारी डिश एंटीना उसी सैटेलाइट को फेस कर रही होती है. एंड नेचुरली इफ इट इज ऑन इक्वेटर, देन नॉर्दर्न हेमिस्फीयर से हमारी सारी डिश एंटीना की जो डायरेक्शन होगी वो साउथ की ओर होगी. इफ दिस इज द केस, लेट अस सपोज इन ऑस्ट्रेलिया, then all the dish antenna they will be facing towards the north, because उनके लिए उनकी geostationary satellite अगर इक्वेटर के पास है तो they will be north facing. You understand? So आपने let's suppose ये satellite throw कर रखा है, so earth is rotating and this satellite is also rotating. Now let us suppose some of the programs are going on. एक तो इस टीवी की सारी ट्रांसमिशन अर्थ पे हो सकती है, but if you want to cover the entire globe, then what we do, ये अपलिंक ट्रांसमिशन की जो हमने अभी बात की थी, दिस अपलिंक ट्रांसमिशन इज प्रोवाइडेड टू दिस सैटेलाइट एट अराउंड 6 GHz. नाउ इन द प्रोसेस ऑफ गोइंग, द इंफॉर्मेशन विल बी अटेन्युएटेड. नाउ दिस सैटेलाइट इज वर्किंग एज अ रिपीटर. वो इस सिग्नल को रिसीव करने के बाद फिर फर्दर एम्पलीफाई करेगा, and a part of this signal can be thrown back to the earth, but you can see clearly here it's only 1/3 of the earth that will be covered. You see here, जो आपने यहां पे सैटेलाइट को थ्रू किया और सैटेलाइट ने अगर रिवर्स आपको थ्रू किया है, it's only 1/3 of the earth that is covered. The lower part, side part, they are not covered. To overcome this problem, what you do, आप एक दूसरी सैटेलाइट रखते हैं S2. This is also geostationary satellite. Maybe you can share with some other country, or you can throw your own other geostationary satellite at this location. And similar to this, you can have the third satellite S3, I am naming this side. So you see S1, S2 and S3, these are 3 geostationary satellite, all of them at same altitude. Now what is the use of these satellites is that the signal from this satellite, apart from being sent on the earth, can be sent to these satellites as well. It is being sent here, it is being sent here. Now in that process, you can say again the signal is attenuated. Now those satellites which are working as repeaters, they can really amplify that signal and the rest of the part can be covered. Now ये satellite जो है, ये आपके signals को अर्थ पे इधर भी through कर सकता है. So second 1/3 will be covered. From here also the rest of the 1/3 is covered. And this is the way you have across the globe communication 24 hours. आज जैसे आप कोई भी ईमेल करते हैं और across the globe वो कहीं पे भी पहुंचना चाहिए. So maybe you can think that this signal is going to the satellite and getting reflected onto other satellites and covered to any place on this earth. In case you are not placing geostationary satellites, then this kind of communication will not be possible. For example, I had mentioned that before 1962, we do not have the technology for throwing the geostationary satellites. उससे पहले जो भी हमारी कम्युनिकेशन थी, मे बी दैट वॉज ऑफ गुड क्वालिटी, बट इट्स रेंज वॉज वेरी स्मॉल, मे बी फ्यू 40 किलोमीटर्स 50 किलोमीटर्स. बट इन केस यू आर ट्राइंग टू इंक्रीज द रेंज, then geostationary satellites are the ones which can give you a very larger range. A problem with these satellites is that they are quite far off from your earth, around 36,000 kilometers. So in case you want a very clear cut picture of the entire earth, then you will have to have a satellite which is roaming at a smaller distance, and so that you can have better remote sensing. So for that purpose we have another kind of satellites which you call polar satellites, and let us discuss that. Now the second category of satellites we happen to throw, that is called polar satellites. जो लास्ट कैटेगरी थी जियो स्टेशनरी सैटेलाइट, वो इंडिया के केस में इनसैट के नाम से जानी जाती है, दैट इज इंडियन सैटेलाइट. एंड दी पोलर सैटेलाइट्स की इंडिया में जो नेम है, दैट इज IRS, दैट इज कॉल्ड इंडियन रिमोट सेंसिंग सैटेलाइट्स. दीज आर दी सैटेलाइट्स विच आर एसेंशियली पोलर सैटेलाइट्स. नाउ व्हाट इज द लोकेशन ऑफ द पोलर सैटेलाइट्स? अगर आप अर्थ की सिचुएशन देखें, लेट्स सपोज दिस इज द अर्थ, देन पोलर सैटेलाइट की ऑर्बिट जो है वो इस तरीके से है, इज अराउंड 60 डिग्री फ्रॉम द नॉर्थ साउथ पोल यू हैव, and these satellites are rotating. Indian remote sensing satellites or polar satellites you can say. The altitude is approximately 900 kilometer. आपने जो जियोस्टेशनरी सैटेलाइट देखी थी उसकी अगर हम लोकेशन दिखाएं तो जियोस्टेशनरी सैटेलाइट्स यहां के ऐसे ऑर्बिट में इधर से रोटेट कर रही हैं, एंड अप टू अ डिस्टेंस ऑफ 36,000 किलोमीटर. यू अंडरस्टैंड? अगर आप कंपेयर करें कि जियोस्टेशनरी सैटेलाइट किधर है और पोलर सैटेलाइट्स किधर है, तो जियोस्टेशनरी सैटेलाइट इज ऑन द इक्वेटोरियल प्लेन. रिमेंबर दैट कोई भी सैटेलाइट अगर रोटेट करेगा तो उसकी इलिप्टिकल या सर्कुलर ऑर्बिट की जो फोकस है, दैट मस्ट कोइंसाइड द सेंटर ऑफ द अर्थ. यू सी, दिस इज द बेसिक रिक्वायरमेंट फॉर अ सैटेलाइट टू मूव. So now the position of the geostationary satellites is on the equatorial plane, but जो polar satellites हैं वो इस तरीके से कुछ एंगल पे रोटेट करती हैं, because they are closer to the poles, they are covering the major area of the poles, so they are called polar satellites. Now naturally in case they are rotating at a height only of 900 kilometer, इनकी टाइम पीरियड कम हो जाएगी, because as per Kepler's law you have seen, ये रेडियस जितनी ज्यादा होती है टाइम पीरियड भी उतनी ही ज्यादा है. approximately you will see the time period of this rotation is around 70 minutes. एंड उस पर से भी अगर इंडिया में इसकी कवरेज देखें तो अप्रोक्सीमेटली फॉर 4 मिनट्स इट इज ओवर इंडिया. नाउ इफ यू वांट दैट ऑल द टाइम देयर शुड बी अ पोलर सैटेलाइट ओवर इंडिया, then at least 15-16 satellites in sequence it should be rotating, and then only you will covering the entire earth, isn't it? इंडिया के ऊपर में जो भी हमारा लैंड है उसको कवर करने के लिए आपको एटलीस्ट सीक्वेंस में so many satellites चाहिए होंगी. The major use of this satellite is for remote sensing. If you talk about the use of geostationary satellites, then they are mainly for communication purpose and you can say weather forecasting. But if you are talking about remote sensing, then it is better with this polar satellites because इनकी height जो earth से है that is less. So in case it is doing photography, that will be more clear. And you see it is using different waves for doing photography. It is not only optical waves. Rather, let's suppose the clouds are there, it will be using some other waves. Let's suppose you have to take the photographs at night of moving objects, then it is using infrared camera because infrared are the ones which are, you can say, from the live body the heat waves are coming up. So infrared camera happen to be more useful in night picture capturing, and all types of, you can say, secret information or any information of different purpose can be collected with the help of the remote sensing or the polar satellites. Now once you have understood the satellite communication, now let us talk about the line communication, in which the only category we will be talking about, and that is optical communication or optical fibers. So let us talk about optical communication. In the category of line communication, we are just confining ourselves to optical fibers because they are the fastest mode of communication right now in line communication. Earlier we used to have that cable, but gradually the use of cable is being avoided because of several reasons. फास्टर कम्युनिकेशन चूंकि हमारी ऑप्टिकल फाइबर से पॉसिबल है, इसीलिए आज हम ट्राई करते हैं कि मैक्सिमम ओल्ड केबल्स शुड बी रिप्लेस्ड बाय न्यू ऑप्टिकल फाइबर्स एंड केबल्स. सो लेट अस डिस्कस द स्ट्रक्चर ऑफ ऑप्टिकल फाइबर एंड द वे इट इज कीपिंग द कम्युनिकेशन. Try to see what is the kind of structure you have in the optical fiber. If you consider the microscopic view of an optical fiber, then essentially you have a transmitting medium here over which you have a cladding. If you consider the thickness of this thing, you can say 50 microns around is the thickness of the central cylindrical transparent medium, and almost same cladding you have, say 25 microns. If you try to understand the thickness microns, then total 100 micron thickness is same as the writing paper you have. अगर आप अपने नोटबुक की राइटिंग पेपर की थिकनेस को चेक करके देखिए, वट एवर थिकनेस यू फील देयर, दैट इज 100 माइक्रॉन्स. सो ये पूरी थिकनेस मैंने उतनी दिखाई है जितनी की आपके नोटबुक की पेपर की थिकनेस है, अंडरस्टैंड. और उसकी माइक्रोस्कोपिक व्यू इनलार्ज करके मैंने ऐसे दिखाई है. अगर आप स्मॉल स्केल पे इसको देखें तो ऑप्टिकल फाइबर अगर बेंट शेप में भी है, फ्रॉम वन एंड द लाइट एंटर्स. अगर आप यहां से देखें तो लाइट इज एंटरिंग हियर. इस पर्टिकुलर लाइट की यहां पे देखें तो एक रिफ्रैक्टिव इंडेक्स इसका N1 है, इसकी रिफ्रैक्टिव इंडेक्स N2 है, और जो बिल्कुल बाहर की मीडियम है, लेट अस सपोज इट्स रिफ्रैक्टिव इंडेक्स इज N0. यहां पे N1 इज ग्रेटर देन N2, रिमेंबर दैट. जो इंटरनल ट्रांसपेरेंट मीडियम है उसकी रिफ्रैक्टिव इंडेक्स ज्यादा होती है कंपेयर टू द क्लैडिंग, एंड पर्पसली वी कीप लाइक दिस सो दैट जब इसमें लाइट यहां से एंटर होके यहां जाएगी तो इसका टोटल इंटरनल रिफ्लेक्शन होना चाहिए. यू कैन से काइंड ऑफ क्रिटिकल एंगल यू विल बी हैविंग, और उससे फिर लाइट की टोटल इंटरनल रिफ्लेक्शन होगी. इस एस्पेक्ट को अगर आप यहां पे दिखाएं तो इसकी टोटल इंटरनल रिफ्लेक्शन इधर से भी होगी, इधर से भी होगी, एंड द लाइट सिग्नल सिंपली कीप्स ट्रैवलिंग इनसाइड दिस ट्रांसपेरेंट मीडियम. ऊपर की क्लैडिंग इसे बाहर नहीं जाने देती. दिस इज द क्लैडिंग. क्लैडिंग is doing the work of total internal reflection. This kind of optical fiber you must have seen in some of the fancy table lamps, in which you must have seen there are a lot of fibers, and at the tip of all these fibers the lights are coming out. This is essentially optical fiber, and communication is faster because light is traveling, और light की frequency बहुत ज़्यादा है, 10 to the power 15. Now here, if you consider the entire aspect, you see this light, whatever angle it is making with the axis, that is called the entrance angle. I am denoting it by theta E. You see theta E, this is the entrance angle, and we are expected to find out an expression for this entrance angle. Here you can see N0 is the refractive index of the outside medium, say air, and N1 is the refractive index of the medium inside. Now let's suppose I call this angle to be theta r. ये रिफ्रैक्शन की एंगल होगी. आप कह सकते हैं दिस इज एंगल ऑफ इंसिडेंस एंड दिस इज एंगल ऑफ रिफ्रैक्शन, एंड द कॉम्प्लीमेंट्री एंगल विच यू हैव हियर, दिस C, द सम ऑफ दीज टू, दैट इज 90 डिग्री, एंड C मस्ट बी इक्वल टू द क्रिटिकल एंगल. या तो ये एंगल क्रिटिकल एंगल होगी या उससे ज्यादा होगी. सो लेट अस ट्राई टू डिराइव दिस थिंग फॉर द क्रिटिकल एंगल. Now going by the Snell's law, you can say N0 into sine theta E, this is equal to N1 into sine theta R. This is essentially the Snell's law, isn't it? Mu1 sine theta 1 is equal to mu2 sine theta 2. Here we are using, instead of mu, the number n. The letter n is representing the refractive index. So N0, you can see here N0 sine theta E is equal to N1 sine theta R. Now you see what is the relation between theta R and C. They are away from each other by 90 degree. That means the sum of these two, that is 90 degree. So you can also write it as N1 sine 90 degree minus C. That is same to say N1 cos C. C is the critical angle. So this is N0 sine theta E. Now if you see the value of this critical angle, already you have a formula. If you remember, sin C is equal to 1 by mu. Now what is mu here? Mu is N1 by N2. So 1 by mu is what? N2 by N1. So you also have sin C as N2 by N1. N2 की वैल्यू देखिए लेस है, N1 की वैल्यू ज्यादा है. So here sin C can also be written as N2 by N1. So using the trigonometry, what do you think? What will be the value of cos C? The value of cos C will be 1 minus N2 upon N1 square under root. That is same thing to say N1 square minus N2 square under root divided by N1. Isn't it? This is the expression of cos C. Now if you substitute it here, you can have N0 sine theta. This is N1 multiplied to this, so this will become equal to N1 square minus N2 square. You understand? Based on that, you can have the expression of the entrance angle defined in terms of sine theta as the final formula N1 square minus N2 square upon N0. This is the final formula you will have, so that you can calculate the entrance angle. You understand? So some of the direct questions can be asked based on this. You have N1 square minus N2 square square root upon N0. You try to see N1 will be largest, that is the refractive index of the transmitting medium. N2 will be lesser than that, that will be the refractive index of the cladding, and N0 is the refractive index of the outside medium. So that is all you have in your concluding lecture of communication system. So now before I move ahead, let me all summarize what we discussed in our today's lecture. In today's lecture of communication, first we talked about the bandwidth of signals. Then we talked about the bandwidth of transmission medium. In which we gave a special consideration to space transmission and various channels you have in space communication. So it was also pointed out that the values which we mentioned in the form of tables, that is very important, because most of the time in the exam you are directly asked those values. Then we had different communication channels. In which first we talked about the space communication, जिसमें हमने ग्राउंड वेव्स, स्काई वेव्स और स्पेस वेव्स के बारे में बातें की. देन वी टॉक्ड अबाउट सैटेलाइट कम्युनिकेशन, in which we talked about two types of satellite, geostationary satellite and polar satellites. And then we had line communication, in which we talked about optical fiber, and we derived the expression for the entrance angle for the optical fiber. And essentially, with the help of this particular discussion, we have come to the end of the chapter of communication systems. And that is all we have for today. Thank you.